Lesson 12.2 and 12.3. So here we're going to combine two different sections just because they're really short ones. I figured these could be combined into a single lesson. We're going to learn a little bit more on angles, and we're going to start delving into shapes, specifically triangles. So your goal is to understand how to classify various types of angles and triangles. All right, so we've already talked a bit about angles in the last lesson, but we're going to add just a little bit more onto it, which is the idea of complementary angles. And sorry about the blurriness, just the cut and paste. The source was a little low resolution. So complementary angles are when two angles add up to 90 degrees. And so here's some examples down below. I've got this example where I've got a 30-degree angle and 60-degree angle. Notice how they're not touching, they're separate angles. But because they add up to 90, that makes them complementary. Or you can have a situation like this, where you can have two adjacent angles, and because the two of them together have a right angle label here, that makes them complementary as well. And so one thing to think about is we are going to talk about something similar to this called supplementary angles, and the two are easily mixed up. So right now I would try to come up with a way to remember that complementary is 90. I've had some people say that, starting off writing the C for complementary is the same way they start off writing a 9. But whatever works for you in terms of remembering that complementary goes with 90 degrees, commit that to memory so you don't get the two mixed up. All right, so here's where we might use that kind of information. Now let's see if I can draw this on this equipment. The measures of two complementary angles are x degrees and 2x minus 3 degrees. Solve for x. So in other words, they're telling us that these two angles add up to 90 degrees. So if I were to draw this picture, it would look something like this. And again, this is going to be a horrible picture. I'm using a tablet, and it's a little hard to write. So there's our 90 degrees. So one of the angles is labeled x degrees. The other is 2x minus 3 degrees. But the important thing is that we know that these are complementary angles that add up to 90 degrees. So the work that we would show would be the first angle, x, plus 2x minus 3, the other angle, and we know that they're complementary, which means they add up to 90 degrees. So here we can just pull out our knowledge from chapter 1 and simplify and solve. So first I've got some like terms. We'll make that x plus 2x, which is 3x. And now we can start solving things. First thing I would do here is get rid of the minus 3 by adding 3. And we get this. And then divide both sides by 3. So x is 31 degrees. Now, if I were to plug this back in, that means this one's a 31 degree. Scratch that. That means this one is a 31 degree angle. And then this would be, let's see, 2 times 31 is 62. 62 minus 3, this would be a 59 degree angle. 31 plus 59 is 90 degrees. Okay, so like I said, there's another thing called supplementary, which is very similar. And the only difference is with supplementary, two angles are supplementary angles when the sum of their measures is 180 degrees. In other words, they form a straight angle. So like here, one angle is 135, one's 45, that adds up to 180. Or I can just visually see that the two angles are next to each other, side by side, on a straight angle, which makes them supplementary, because we know straight angle is 180 degrees. Now, just like complementary, have a way to remember this so you don't get the two mixed up. I've had people say that the beginning of the S, writing an S, is like starting the 8 in 180. But whatever works for you to help you remember and keep complementary and supplementary separate. All right, so let's try a problem like that with supplementary. The measures of two supplementary angles are n and 5n. Solve for n. In other words, once again, this is their way of saying that n and 5n, when put together, add up to 180 degrees. So if you want to visualize that, and I'm going to just put it on this picture, let's call this one n, and then this one is 5n. That's what our visual would look like. Okay, so here, simplify and solve. 6n equals 180 divided by 6, and equals 30 degrees. So that makes this angle 30 degrees, makes the other one 5 times 30, which is 150, and they add up to 180. All right, so that's our piece on angles, complementary and supplementary angles. Now let's take a look at triangles. All right, so what we're going to do in the next few slides is we're going to learn to classify triangles in two different ways. The first way is by using its angles. So notice these four. I've drawn each of these because when it comes to their angles, each one's slightly different. Now the one you'll probably recognize that we've seen quite a bit of is this bottom left one. Notice how it's drawn in a particular way where this angle right here kind of stands out because that was meant to be a 90-degree angle. And so just like with angles, we would consider this bottom left corner a right angle. Well, then classifying a triangle, we call it a right triangle. So a right triangle, all we care about is that one of the angles is equal to 90 degrees. The other two doesn't matter. But if it's got one of the corners as a right angle, that makes it a right triangle. Now another one that you might recognize is this one. Okay, this looks like an equilateral triangle because all the sides are the same, but we're looking at the angles. And so this has a very similar definition where it's not the sides we're looking at, but it's the angles. This angle and this angle and this angle were all meant to be drawn as equal angles. And so we call this an equiangular triangle, where all three angles are congruent, equiangular. All right, and then these two. Now these two just look like random triangles, but there's certain things about them that classify them. So this one, what you'll notice is that what makes this special is that all these angles, this one, and this one, they're all less than 90 degrees. They're all acute angles. And so based on that, what we know about their angles, then we call this an acute triangle. All right, so if all the angles, every single one of them is less than 90 degrees, then it's an acute triangle. And then finally, what makes this one special is this particular angle right here. That the other two, it doesn't matter, but what's special about this one is that this is larger than 90 degrees, which is an obtuse angle, which makes it an obtuse triangle. So obtuse triangles, one angle is greater than 90 degrees. So the nice thing about this is we've already kind of looked at this in the last lesson. Acute angles, well, with a triangle, all the angles are acute, it's an acute triangle. We know what an obtuse angle is, and if our triangle has one of them, that makes it an obtuse triangle, and same thing with a right triangle. So the only one that's kind of new to us is this equiangular triangle, all three congruent angles. All right, but as I said before, this is not the only way to classify triangles. We've just classified the triangles using their angles. There's a whole separate way to classify these same triangles here. All right, so in here I've got only three. Now once again, this one we were talking about before, this was the equiangular one on the last slide, but in this case now we are classifying using sides. So don't look at the angles anymore, look at the sides and what makes them special. And so let's start off with this one down here. It's an equiangular, but that also means that these sides are all equal. And so this is the more familiar definition that we've seen is equilateral, three congruent sides. Now, what makes this one special, again, not looking at the angles, but the sides, is that this was drawn with this side being equal to this one. Two out of the three sides are congruent. This is called isosceles. I don't know if it's the same for you guys. I always have trouble spelling this. I always forget the second S here. I-S-O-S-C-E-L-E-S. Isosceles. Two congruent sides. And then this one, what's special about the sides of this one is that this side and this side and this one were all drawn with the intention that all three sides are different. None of the sides are congruent, which is called scaling. Scaling has no congruent sides. And so now when they ask you to classify a triangle, you now have the two different ways of classifying it, by its angles and by its sides. So when I give you a problem like this, you go through those different definitions and find the right one. So if I first look at angles, well, what's special about these is that, well, this one is larger than 90 degrees, which is an obtuse angle, which makes it an obtuse triangle. Now if I look at the sides, all three sides are different measurements, which makes it scalene. So this is an obtuse scalene triangle. One last one. Classify this triangle. Now again, if I look at just the angles and I ignore everything else, I notice specifically that I have a right angle, which makes this a right triangle. If I look at the sides, and it's a little hard to see on this, these two sides were meant to be the same length, which makes it 2 out of the 3 sides congruent. The definition was isosceles. So it's a right isosceles triangle. Okay, so that was a little bit more on angles and a whole lot of vocabulary on classifying triangles. And this is what you'll need to do the work in these lessons.